Hey guys, today we're looking at lessons 1.3. If you want to pause the video for a second and go to your textbook and find lesson 1.3, that would be a great thing to do. Alright, so today we're going to look at transformations of function graphs. Alright, it says perform a one-step transformation. Alright, the solid curve function is f of x and the dotted curve function is g of x. So you can see on the graph here the solid one, that would be f of x, the dotted one is g of x. How do the equations for these functions relate? To find how f of x relates to g of x, you can compare points on the same x coordinate. Well, if you look at this graph, hopefully you can see that it looks like f of x, or the solid curve, has just been shifted down 4 units. You can see that's 0, -4, so these are going by 2's. So it's been shifted down 4 units. If you look at this one, it goes from 12 down to 8. And when we say down, we're looking at the y values, or the f of x's, because that the vertical line, that is your y values, that's your f of x. All right, so 12 goes down to 8, so that one's shifted down 4. And here's 2 more points. You can see that this one goes from, it looks like that one goes from 3, 1, 3 to 1, -1. So from 3 down to -1 also shifts down 4. So basically you're looking at the exact same graph, and the whole thing has just been slid down 4 units. All right, if x equals 0, we are given f of 0 equals 0 and g of 0 equals -4. So again, the f of x function you can see right here, it was at 0. When you have x is 0, f of x, or your y is 0 as well. And g of 0, when g of x is the dotted line, when it's 0, when you substitute 0 in for x, you get -4, so it's been shifted down. We can use the variable k to represent the change in the function, and we can solve for k using the equation f of x plus k equals g of x. So 0 plus k equals -4. All right, so you can add or subtract numbers to solve for the variable, but when you have a 0, it's not really changing anything. So basically k equals -4. This means that the function has been translated down 4 units. Let's look at 2 other points, beginning by comparing the values of x equals 1. So let's go back to x equals 1. It says f of 1 is 3 and g of 1 is -1. So 3 plus k, okay, again k is -4. 3 plus k is -1. And then it says k equals -1 minus 3. So if you can just combine those, we're going to get -4. All right, to find how f of x relates to g of x, you can also compare points with the same x coordinate. Next, compare the values if x equals -2. All right, so if we go up here and look, when x is -2, f of x was 12. And -2, g of x was 8. So when you see this 12 and 8, that's coming straight from the graph right above. All right, so it says, therefore, 12 plus k equals 8. Remember, k is our -4 now. So 12 plus -4 equals 8. But 12 is also, that's what we started with right here. And so we've got 8 minus 12. 8 minus 12 is -4. So we can say that g of x equals f of x minus 4. All right, if we once again call the solid curve f of x and the dotted curve g of x, then we notice that g of x appears to be a reflection of f of x. But it is not. If we reflect f of x, then we get the following numbers. All right, so now they're looking at the graph below, okay? All right, so it says find the value of g of x. All right, so it's still talking about the dotted curve. They're still calling, I think, the solid curve f of x. Yes, the solid curve is f of x and the dotted curve is g of x. All right, so it says find the value of g of x. So if x is 0, g of x is the dotted line, remember? At 0, g of x is 2. So we're simply going to drag the 2 above. And then what happens at 1? So at 1, it's going to be 3. Positive 3 because we went up. Okay. Find the function g of x. We see that g of x appears to be equal to the reflection of f of x shifted up 2 units. So we can say g of x is a reflection makes it negative and then shifted up 2 units. All right, so this is a little bit about transformations. We'll continue in the next video. If you have questions, please let me know.